So for section 9.3, we're going to be doing operations with functions. This is basically, these are the notes here that you should have on your note card and kind of the notes for the main part of this section. But we can add functions. F plus g of x is how we write that. What does it mean? We add f of x plus g of x. They will write the question like this, and your first step will be to write it out, and then we'll replace and solve. We can add it. We can also subtract. If I have f minus g of x, we are taking f of x minus g of x. Keep in mind the order matters. So if f minus g of x, the f goes first. If I did g minus f, the g, and then the g would go first. Okay? F times g, that means I'm taking the two functions and separately multiplying them. And last, f over g means we're what? I don't know, running out of colors, right? Ooh, that's horrible. That's all right, I'll leave it anyway. F of x over g of x. The key on this one, make sure, and we're going to not really build on this till later, but when I am dividing, put a little asterisk here, because in every case, the domain and the range are any restrictions on either of the functions, so any restrictions we've had from the previous functions, or in f of x over g of x, whatever's in the denominator cannot equal 0. So that little asterisk, whenever I'm dividing, that denominator cannot equal 0 as well. So we'll be talking about domain and range. We've done that before algebraically. That's what we're going to be doing here. Let's go ahead and work through this section. Here's an f of x and a g of x. How would you do f plus g of x? Well, like I said in your notes, write out what does that mean. It means f of x plus g of x. What we now do is we go back to these functions and we replace them with what they're worth. F of x is worth 2x squared minus 3x plus 4. G of x is worth x squared plus 9x minus 5. So we replace them so that f plus g of x is equal to f of x plus g of x. Then we simplify that, combining like terms. We have, looks like 3x squared plus 6x minus 1. And that is what f plus g of x would look like. Why do we do this? Once again, I blame the scientists, because in nature the idea is that we actually have functions that feed into functions. And so rather than deal with them individually, I can now create this combined function that shows two functions combining or adding to each other. So what if I wanted to do f plus g of 2? Well, we've done this before. I'm going to focus on the left one. I know what f plus g of x is, right? So f plus g of 2 just says go to our new combined function and stick a 2 in place of that x. So it would become 3 times 2 squared plus 6 times 2 minus 1. I can put it into our new function we created there. So it becomes 3 times 4, or 12, plus 12 minus 1. It becomes 23. That is what f plus g of 2 is. Or, if I didn't have this combined function, could I have plugged it into them individually, right? Separately. Absolutely, right? But the idea is our combined function, most of the time, is going to save us work once we have that combined function. But f plus g of 2 means f plus 2 plus g plus 2. F of 2 plus g of 2. What is f of 2? 2 times x squared minus 3 times x plus 4. 2 times 4 is 8 minus 6 plus 4. How about, I want to say 6. So f of 2 is equal to 6. What is g of 2? 2 squared plus 9 times 2 minus 5. 4 plus 18 minus 5. How about 15? So g of 2 is 15. Just looking at something because I think I messed up somewhere, because these aren't adding to 23. So let's see. 4, 8, 6, and 4. 4, 18, 22. Oh, this is 17. That's why. So you're like screaming at your screen. Learn to do math. Alright, fine. So what can I do here? If f of 2 plus g of 2 is f plus g of 2, I can do f of 2, 6, plus 17, f plus g of 2 is 23. Which answer's right? They both got the same answer, right? Which one's easier? Well, in this situation, it was easier to combine it, plug it into the composite function, but you needed the composite function first. So there will be some homework questions that start with this, and it's easier to plug it in and then just get your answer than do all the work at the beginning. But there's pros and cons to both, okay? You can expect I will need you to make composite functions here with just the x, and that you'll have to plug numbers into those. We said we could add. We can also subtract. F minus g of x means f of x minus g of x. I have a new little jog in my memory. What is f of x worth? That was, let's see, two x squared minus 3x plus 4. 2x squared minus 3x plus 4 minus g of x was x squared plus 9x minus 5. X squared plus 9x minus 5. Okay, this would be wrong, because we have to subtract away the entire g of x. We have to subtract away the entire group. So, about 2x squared minus 3x plus 4 minus x squared minus 9x and plus 5. So combining like terms, looks like we're left with x squared minus 12x plus 9. And that is what f minus g of x would be. We can subtract the functions. How would you do f minus g of 2? Well, I'd plug a 2 in to this function, not the 12, in place of the x. So 2 squared minus 12 times 2 plus 9, 4 minus 24 plus 9. How about negative 11? Isn't this, though, the same thing as f of 2 minus g of 2? Well, I did that earlier. What was f of 2? F of 2 was, so 6 and 17. So it'd be 6 minus 17 this time. The same numbers, just now we're subtracting them. What's 6 minus 17? Negative 11. The answer doesn't change. It shouldn't change. That's kind of the point. If it changed, we would have done something wrong. This new function, I can plug the number in once, and it's like plugging it into each function and then subtracting them. We can add, we can subtract, we can multiply. What does f g of x mean? It means f of x times g of x. Means f of x, 5x minus 3, times g of x, 3x squared plus x. Do not leave it like this. We will distribute. So 15x to the third, 5x squared, minus 9x squared, minus 3x, 15x to the third, minus 4x squared, minus 3x. That is fg of x. What would you do for fg of 1? 15 times 1, minus 4 times 1, minus 3 times 1, 15 minus 4 minus 3, I believe is just 8. Or I could have done f of 1 times g of 1. And it should be the same answer. What is f of 1? What is 5 minus 3? What is g of 1? What is 3 plus 1? So f of 1 times g of 1 would be 2 times 4, would still be 8. The answer doesn't change. So that line's driving me crazy. The answer doesn't change if I plug it in separately. That's kind of the point of what we're doing. Just real quick, what would f of x be? Well, f of x was the 5x plus 3, I believe. Check. 5x minus 3. So this would mean itself. See, it's f twice. So it would be 5x minus 3 times 5x minus 3, about 25x squared minus 30x plus 9. So make sure that you know that we don't always just multiply the functions by each other. Sometimes we can do f times itself. We can have a function times itself. We can add, we can subtract, we can multiply, we can divide. F of x over g of x. F over g of x, sorry about that, f over g of x is f of x over g of x. What is f of x? X cubed plus 2x squared plus 12x plus 24 all over x plus 2. All done. Probably not. You should check and see if this factors. See, check that. That has 4 terms. The first two have an x squared in common. The second two have a 12 in common. So that we end up with x plus 2 times x squared plus 12. Bring it back up. So x plus 2 over x squared plus 12 all over x plus 2. Well, that's cool because it simplifies to just x squared plus 12. And that is what f over g of x would be. Well, let's see plugging in what plugging into this is going to do. Alright, sorry about that. Alright, so f over g of x is, we have x squared plus 12. So f over g of negative 5 would be negative 5 squared plus 12. Negative 5 squared would be 25 plus 12 would be 37. Would that be true if I had separated it f of negative 5 over g of negative 5? Well, let's check. F of negative 5 would have been, what's the f? Oh lordy, negative 5 cubed plus 2 times negative 5 squared plus 12 times negative 5 plus 24. So that would be 125 plus 50, negative 125 plus 50 minus 60 plus 24. So 135, I got negative 111, I believe. That doesn't seem quite right, but we'll see. Over g of negative 5 would be negative 5 plus 2 would be negative 3. What is negative 111 divided by negative 3? Would be positive 37. It gave us the same answer. It's supposed to, right? Be careful though, because What is f over g of negative 2? Somebody's like, well, that's easy. You just plug in negative 2 squared plus 12. 4 plus 12. 16. This is wrong. Why is it wrong? Because f over g of negative 2 means f of 2 over g, f of negative 2 over g of negative 2, right? And so, okay, f of negative 2 would be 8 plus 8 is 16 minus 24 plus 24. I think we're just left with 16. Yeah, there's the 16. Divided by g of negative 2 would be, what is negative 2 plus 2? That is not allowed. You have to remember that when I have an f over g, that means to check the domain that the bottom function, g of x, cannot equal 0. And what was g of x? X plus 2 cannot equal 0, which means that x cannot equal negative 2. So this does not work. Even though algebraically this worked, it's wrong because of the original function. This is why we said the domain will be any restrictions in the function and any restrictions created, meaning the denominator cannot be 0. We know that g over g of x, that makes sense that g over g of x is 1, because g of x divided by g of x is 1, right? G of x was x plus 2, so g over g of x would mean x plus 2 over x plus 2. So g over g of x would equal 1, sort of. Make sure you verify that denominator cannot be a 0. Because, see, if I just had a function of 1, there is no restriction in and of itself. But the fact that one of these is a denominator creates the fact that x plus 2 cannot be 0, so that x cannot equal a negative 2. I can show this to you. The calculator actually kind of does handle this. If I graphed x plus 2 divided by x plus 2. So if I graphed x plus 2 divided by x plus 2, anything divided by itself is 1. It just graphs 1. But there's a hole in this graph. I don't see a hole. Well, we just said x cannot equal negative 2. There's a hole right here. They don't show it to us, but it's there. One way to see it would be to look at the table. If I can remember how to look at the table. How about I click the button table? Look, what do we say? Anywhere x is equal to anything, I'm getting a 1, I'm getting a 1, I'm getting a 1. But what happens when we go up? Right there. At negative 2, this graph is undefined. Why? Even though it simplifies to a 1, there's an original restriction that says that x cannot equal negative 2. There's a hole right there at the negative 2. This graph would literally be except at negative 2, there would be a gaping hole because x cannot equal negative 2. Okay? So that is, I get it, that's a little confusing. This section shouldn't be too bad, but that just goes back to, they're going to have you check domains. And when they have you check the domains, in every case, the domain is any restrictions for f of x or g of x. Also, if I have the fraction, if I have f of x over g of x, that denominator cannot be 0. Okay? So that's it. You're now ready for the next test. Keep it up.